up to 100 up to 1 kilometer in the sky. Yeah, this is not a normal kite here. This is called a parafoil kite, which you might have observed in beach side. You use for surfing near the beach and all, using kite. So it can pull a human being. Why not? It can pull a wheel and produce rotating motion so that we can produce electricity. So the kite I have used here is a 4-line kite. It has four lines. The top 2 lines are called the power line, which pulls, and bottom 2 lines are called the braking lines, which can use for braking the kite or controlling the kite to steer in the sky. As the kite flows in the sky, I mean it flies in the sky, it is not stable, right? It has to be controlled. These 2 wheels do that job, control, and these 2 top threads are connected to this wheel, so it will pull this wheel. And this is a chain drive connected to the generator. You might have one question here, why I have introduced this chain drive here. But why? Because if I connect this thread directly to the generator, it will pull suddenly and it will go, this thread will get over very soon, because thread length here is not infinite, right? It will finish at one space. So if I rotate this slowly, if I rotate 1 round, that will rotate 81 times. So 1:81 ratio I have using this chain drive. So I will get a high RPM, as well as slowly this will get unwind. So you might have one more question. I have some limited thread here. What will happen if it reaches the maximum peak? So after it has reached one position, what we'll do is we will take the kite to a 12 o'clock position, means above your head. What happens is the wind is not tangential to the kite. If the kite is like this, wind is hitting the kite, right? If it is like this, the kite is stalling, like it wants to come down, it will break down. That time we have these 2 threads like free flown in the sky, so we can easily wind it back, right? So we'll wind it back using these 3 motors. So yeah, winding back. So 1 minute 45 seconds are needed to wind it back, and 100 meters is unwinded for about 5 minutes 20 seconds. So we have a transition phase as well as a recovery phase. In transition phase, we will rotate this generator and produce electricity. In recovery phase, we will spend little amount of power to wind it back. So the key element of this project is like, we can transport it to any place, this project, and we can fly the kite in required place, unlike the rigid structure, and it is very economical. We can fly easily in any places. The kite is very economical, and also it doesn't harm birds. You might be pleased to see a kite flying around in the sky rather than a big fan which produces hissing noise and as well as harms birds. Yeah. So you see here a circuit, that is a microcontroller, which measures the input voltage, which shows the status, and its charge also controls the voltage coming, and it charges a DC battery here, I mean 12-volt battery. So this, by storing this in a transition phase with a huge amount, we can invert the battery and give it to a household. So this storing is done in the transition phase. You can compare with the conventional wind turbine with the same cost, you won't get this power because the wind is not continuous here, right, in this altitude. Yeah. So as it goes high and high, the pulling force is very high. The kinetic energy is converted into rotatory one. So this kite is not available here in India. We bought it from China using eBay. Yeah. We got it around for 4,000 rupees.
Hello, we are from Sambram Institute of Technology, Bangalore. Our project is titled Seaman. Seaman stands for Satellite and RF Enabled Assistance for Marine Navigation. It is done to tackle 3 problems faced by our fishermen. The 3 features of our project are border determination and alerting, sudden weather change alerting, and distress SOS messaging. Coming to feature number 1, the border determination and alerting. We are using RF towers at 3 borders of this thing. We are made the Indian border, the international border, and the other country border. Each tower has a FM transmitter in it, and on the boat there has a receiver. Coming to the demo, On the boat, the receiver decodes and switches on a particular LED. When the boat is in the Indian border, a green LED is switched on. As it moves out to the international border, a yellow LED, and for the other country border, a red LED with a buzzer. So this indicates that the fisherman has crossed and he has to come back. Feature number 2 is called sudden weather change updates. From the base station, we receive sudden weather change updates that we transmit to the fisherman. For example, hurricane 2 and with the local language in Hindi. Maybe if it's an earthquake that has taken place, we just have to press that button from the base station and that particular message is updated. That is with respect to feature 2. Feature 3 is called distress SOS message. Whenever the fisherman is under distress, he has to just press a button and the GPS coordinates is transmitted to all nearby boats and the base station. We have a GPS receiver here and the button is already shorted. So for every 3 minutes, the coordinates are sent to the nearby boats as well as the base station. This is the GPS value of this particular boat. That's how we'll get to know where they are in danger and we can go to that particular location for helping them.
Yeah, this is Shiva Krishna. I am from School of Engineering and Technology, Jain University. Yeah, this is our project. It is a smart solar-based low-cost water filter for rural application. Our main concept is to reduce fluoride and chloride content in bore waters, underground water. So we have built a model for filtration of fluoride and chloride content. So these are the tamarind seeds and coconut shell, where tamarind seeds absorb fluoride content and coconut shell absorbs chloride content. Yeah, we have built a filter in such a way that we have 4 candles. We have the mixture of coconut shell and tamarind seeds in this, and we have placed pebbles in this. It will soften the hard water. We have a sand filter placed here, which absorbs minute dust particles and any other metals. And from here, we pass water through a UV ray tube where microorganisms and bacteria are killed. And we have a flow sensor at last to know how much amount of filtered water is used. And this is to display how much water has been filtered. And for our project, we are using solar power. And this is an electric valve to control the flow of water to the output. 8 to 10 liters per hour.
What is the output of the solar panel? Voltage?
12 volts, 1.8 amps.
When you are going to change this?
Sir, after every 300 liters, we will get a message here, sir. Change conduct. Then we are going to replace that coconut shell and tamarind chips.
This is programmed?
Yes, sir.
Through?
ARM processor. This is to reduce, first of all, our objective is to reduce fluoride and chloride content. Next, it is using renewable energy. Yeah, we are not using any power, we are using all through solar power. And to give a filter water.
We are from VVIT, Mysore. This is a Borewell rescue robot used to rescue the child which has fallen in borewells, abandoned borewells like this. There are existing systems where this one is using digging a parallel well near the borewell, and then a tunnel is made. A man will go inside and the child is brought up. This is a tedious and costly process. And the second one, the robotic arms, this will go inside the same well and it will hold the child, but there is no support to the child from the bottom. So there are chances of child slipping further down. So there is no support from the bottom. So this is our project which will overcome all these disadvantages. This is our project. This is a cylindrical tube which you see here. That is the borewell, model of the borewell. And this disc at the top, it will enclose the surface of the borewell. It will be at the top. And this is a pulley provided with a rope. This rope is tied to the robot. Whatever is inside, that's our robot, and it is tied to that. So using rotation of pulley, we are sending this robot inside the borewell. There is a camera with light source provided here, and we will be continuously monitoring the position of the child using this camera. Once the baby is found, we can see that in our screen, laptop screen. So once that baby is found, we will stop this pulley motor, and then we will trace for a gap between child and wall. There will be a gap between child where it is stuck and between the wall of the borewell. There it is this yellow rod which you see here, that will be inserted, and it has got airbags at the end of it. So once it goes below the child, airbags will be blown and it will cover the entire area under the child. It will provide a cushion like support to the child from the bottom. So it is ensured that child will not go further down. After that, using robotic arms, we will hold the child from the top of it. So there is complete support to the child both from top and bottom. It is ensured that child will not go further down. So again, using pulley motor, we will lift the entire setup upwards carefully. That's how the child is rescued.
We are from MSRIT College, myself Sonal.
I'm Supreeta.
Our project is a real-time text-to-Braille converter. How we can see, blind people cannot see. They have something called Braille. So this is the Braille script where A is represented as a dot, B is 1 and 2, C is 1 and 4. So for them to read anything, it has to be converted into Braille. But in today's generation, everything is super fast. We need information instantly. So printing Braille books takes a lot of time and also a lot of money. So here we have devised a system called real-time text-to-Braille converter, where instantly if I want them to read a text document, I can do it right away instead of having a Braille book being printed. So I'm going to show you the demo now.
This is a PDF file which is already saved on our laptop, and by running this, the text saved in this document will be converted into its respective Braille format in real time. So
here the input given is A, B, C, and the corresponding output, Braille output is here. This is one way to do it. This is one way to do it. Second way is sending data through my phone. The Bluetooth of my phone is connected to the microcontroller using a Bluetooth module. So we've developed an app, Bluetooth app which we have developed. You have to select the Bluetooth module. This is the Bluetooth module. Once it's connected, we can send anything. So here I'm just using ABC as the example. Once I click on send, and when I click on send, it gets converted to the Braille output. So the entire process, it's become really easy and fast for the blind people to read anything they want to. They don't have to really wait and they don't have to be dependent on anybody. So the main application for this is in the teaching field. Now the teacher can have one phone where he can send data and all the students can have this module. So the teaching process becomes one-to-many instead of one-to-one, which is the present scenario.
ಇಲ್ಲಾಂದ್ರೆ ಇಲ್ಲಿಗೆ ಲಾಸ್ಟ್ ಇಯರ್ ಜಾಯ್ನ್ ಆದೆ. ಅದಕ್ಕೆ ಮುಂಚೆ ಇಂದ್ರಾನಗರಲ್ಲಿ ಕಂಪ್ಲೀಟ್ ಆಗಿದೆ. ಅಲ್ಲಿದ್ದೆ ಜಾಬ್. ಆಮೇಲೆ ನೀವು ನಮ್ಮ ಪ್ರಾಜೆಕ್ಟ್ ಹೇಗೆ ಮಾಡಿದ್ದೀವಿ ವಿಡಿಯೋಸ್ ಇದರಲ್ಲಿ ನಾವು ಕಂಪ್ಯೂಟರಲ್ಲಿ ಆಲ್ಫಾಬೆಟ್ಸ್ ಫೀಡ್ ಮಾಡಿದ್ದೀವಿ, ಇಲ್ಲ ಟೆಕ್ಸ್ಟ್ ಇದೆ. ಅದು ನಾವೇನು ಮಾಡ್ತಾ ಇದ್ದೀವಿ ಅಂದರೆ ಅದು ಕಂಪ್ಯೂಟರಿಂದ ಬಳಸ್ತಾ ಇದ್ದೀವಿ. ಅದು ಬಳಸಿದಾಗ ನೀವು ಅಲ್ಲಿ ಫೀಲ್ ಮಾಡ್ತಾವಲ್ಲ, ಒಂದೊಂದು ಆಲ್ಫಾಬೆಟ್ ಫೀಲ್ ಮಾಡಿ ನೀವು ಓದಬೇಕು. ಇವಾಗ ಒಂದು ಡೆಮೋ ತೋರಿಸ್ತೀವಿ. ನೀವು ಟ್ರೈ ಮಾಡಿ ಅದು ಆಗ್ತಾ ಇದೆ. ಯಾವ ಆಲ್ಫಾಬೆಟ್ ಬರುತ್ತೆ ಅಂತ ಹೇಳಿ. ಇದೆಯೇ? ಇದು ಡಿ. ಅದು ಅಲ್ಲ, ಮತ್ತೆ ಇದು ಬಿ. ಇದು ಬಿ, ಸಿ. ನನಗೆ ಯಾಕಂದ್ರೆ ಇದು ಹೊಸದಲ್ಲ, ಏಕೆ ಫಸ್ಟ್ ಟೈಮ್ ಬರ್ತಾರದಲ್ಲ ಅಂದ್ರೆ ನನಗೆ ಇವಾಗ ಫೀಲ್ ಮಾಡಿದ್ದಕ್ಕೆ ಖುಷಿ ಆಯ್ತದೆ. ಯಾಕಂದ್ರೆ ಇನ್ನೂ ಸ್ವಲ್ಪ ಮುಂದೆ ಹೋಗ್ಬೇಕಂತ ಕಲಿಯಲ್ಲಿ ಎಫರ್ಟ್ ಆಗ್ಬೇಕು ನಾವು. ನಿಮಗೆ ಇದು ಹೆಲ್ಪ್ ಆಗುತ್ತೆ ಅನ್ಸುತ್ತಾ? ನನಗೇನು ಆಗುತ್ತಾ, ಆದ್ರೆ ಟ್ರೈ ಮಾಡಬೇಕು, ಬಿಡಬಾರ್ದು. ಥ್ಯಾಂಕ್ ಯು.
Good afternoon. ನನ್ನ ಹೆಸರು ಕಾಜಲ್ ನೆಲ್ವಿಗಿ. ಐ ಆಮ್ ಫ್ರಮ್ BIT ಕಾಲೇಜ್ ದಾವಣಗೆರೆ. ನಮ್ಮ ಡಿಪಾರ್ಟ್ಮೆಂಟ್ ಬಂದು ಟೆಕ್ಸ್ಟೈಲ್ ಟೆಕ್ನಾಲಜಿ ಅಂತ. ನಾವು ಸ್ಪೆಸಿಫಿಕಲಿ ಇದು ಪ್ರಾಜೆಕ್ಟ್ ಮಾಡಿರೋದು ಪೋರ್ಟಬಲ್ ಸೋಲಾರ್ ಗಾರ್ಮೆಂಟ್ ಅಂತ. ಅಂದರೆ ದ ವೇರರ್ ಕ್ಯಾನ್ ವಾಕ್ ಅರೌಂಡ್ ವೇರಿಂಗ್ ದ ಸೋಲಾರ್ ಗಾರ್ಮೆಂಟ್ ಆ್ಯಂಡ್ ವಾಕ್ ಅರೌಂಡ್. ಅಂದರೆ ಅದ್ರ ಬಗ್ಗೆ ಏನು ಥಿಂಕ್ ಮಾಡದೆ ಅದನ್ನು ತೊಗೊಂಡು ಹೋಗೋ ಹಾಗೆ. ಇಲ್ಲಿ ಏನು ಮಾಡಿದ್ದೀವಿ ಅಂದರೆ ಸೋಲಾರ್ ಪ್ಯಾನಲ್ ಯೂಸ್ ಮಾಡಿ ಫ್ಯಾಬ್ರಿಕ್ ಒಳಗಡೆಯಿಂದ ಕನೆಕ್ಷನ್ ಮಾಡಿ ಅದು ಸೋಲಾರ್ ಎನರ್ಜಿನ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಎನರ್ಜಿ ಕನ್ವರ್ಟ್ ಮಾಡಿ ಫೋನ್ಸ್, ಟ್ಯಾಬ್ಸ್, ಐಪಾಡ್ ಎಲ್ಲ ಚಾರ್ಜ್ ಮಾಡುತ್ತೆ. ಸೊ ಎಷ್ಟು ಅಮೌಂಟ್ ಬೇಕೋ ಅಷ್ಟು ಐಪಾಡಿಗೆ ಮತ್ತು ಟ್ಯಾಬಿಗೆ ಬೇಕೋ ಅಷ್ಟು ಅಮೌಂಟ್ ಚಾರ್ಜ್ ಮಾಡುತ್ತೆ. ಹಾಂ, ಇದು ಇಲ್ಲಿ ಬಂದುಬಿಟ್ಟು ಸೋಲಾರ್ ಪ್ಯಾನೆಲ್ ಬರುತ್ತೆ. ಇದು ಸೋಲಾರ್ ಪ್ಯಾನೆಲ್ ಕನೆಕ್ಷನ್ಸ್ ಬಂದುಬಿಟ್ಟು ಇಲ್ಲಿ ಒಳಗಡೆ ಮಾಡಿದೆ. ಬಟ್ ನಾವು ಏನು ಇನ್ನೊಂದು ಫೀಚರ್ ಆ್ಯಡ್ ಮಾಡಿರೋದಂದರೆ ಇದು ಒಳಗಡೆಯಿಂದ ಏನು ಕನೆಕ್ಷನ್ಸ್ ಕಾಣದ ಹಾಗೆ ಇದನ್ನು ಕನೆಕ್ಟ್ ಮಾಡಿದ್ದೀವಿ. ಬರೀ ಕನೆಕ್ಷನ್ಸ್ ಈ ಥರ ಕಾಣೋ ಹಾಗೆ ಓನ್ಲಿ ಕ್ಲಿಪ್ಪಿಂಗ್ಸ್ ಮಾಡಿ ಒಂದು ಇಂಡಿಕೇಟರ್ ಇಟ್ಟು ವಯರ್ಸ್ ಮೂಲಕ ಇದನ್ನು ಚಾರ್ಜ್ ಮಾಡ್ತಾ ಇರೋಂಗೆ ಮಾಡ್ತಾಯಿದ್ದೀವಿ.